So at the end, we'll have a evaluation that you can get your certificate of attendance for, and then that will be how you get the recording and other information. So let me introduce Chuck. I think I've talked enough now. Chuck Mills is the Director of Engineering for the Asphalt Pavement Association of Michigan, APAM, APA. And so Chuck has been with them as their director since 2005. So he's got lots of experience with this. And he's going to talk to us today a little bit about how to read an asphalt mix design. So Chuck, take it away.
All right. Thank you, Ingrid. Can everybody hear me okay? Okay. So first, I want to just kind of go through a couple slides, give you a little bit of basic background. Asphalt mixtures are composed of approximately 94% aggregates. That's your stone and sand, and 6% asphalt cement. Aggregates that we use for asphalt mixtures need to possess certain properties or characteristics. They need to be durable, environmentally resistant. They need to be able to handle traffic wear, et cetera, to meet any requirements of the specifications. Asphalt cements are engineered for the application as well. Any other materials, wrap, RAS, warm mix, recycling agents, rubber, anything else that we're putting into the mixture also has to be taken into account. And really, we talk about asphalt mixes and the mix design process, and what we're doing is putting together a recipe for that asphalt mix. And ultimately, that asphalt mix is made at the hot mix asphalt facility. So we're making a mixed recipe so that we can produce it in the hot mix asphalt plant. So we're combining all those different aggregates and the asphalt cement, any recycled materials, mixing that together at 3, 4, 500 tons per hour to make that mix and send it out to jobs. So that's just a little bit of background.
So Chuck, what goes into creating a mix design?
So what goes into creating a mix design? Our knowns are the binder type that we need to use for the specific application, as well as the mix type. So that gets figured out ahead of time. And then it gets sent over to put together a mix design. And from there, we have to select the aggregates that we're going to use, any recycled materials if we're using any of those. And we put together typically 3 different blends of the aggregates with the same asphalt content and test that and see how that works. Once we come up with what our aggregate blend is that's going to meet all the specifications, then we blend 4 different asphalt contents with that aggregate blend to try to optimize and get our optimum asphalt content. And we do this shooting for 4% air voids. So all the mix designs we do here in Michigan, we design them at 4% air voids. So once we have that, when we know that that aggregate blend at that asphalt content will meet all the specified specifications for your mix volumetrics and whatnot, then we do a moisture sensitivity test on that material. And so what we're trying to do there is to make sure that that mix isn't susceptible to moisture damage, which can cause the mix to unravel and not stick together. So typical time to complete all of this takes about 2 weeks to go through that whole process if we're starting out a new mix design. So it's not something that we just throw a bunch of materials together and have it done in a day.
All right. So not an instant process. So why should I want to see that mix design?
The main reason is, you want to make sure that the mix that's coming out to your job is going to meet the specifications. And some of that is done, you have your design. So hopefully the design was done correctly and you've designed the right mix for your application. And now you want to see that the mix design, that recipe that they're using back at the asphalt plant to make that is going to make is going to meet those specifications.
Okay. So, you said that it takes a little bit of time to do this. So what happens, maybe I don't have time. How long is the design good for? What if I have an old design? Can I use an old design?
You can, at least with the MDOT mixed design process, and I'll talk a lot about that today just because we are in Michigan and the Michigan Department of Transportation has a very detailed process that they go through where when the mixed design gets submitted to them, they're doing all the testing to make sure that it's meeting all those specifications. And any mixed design that gets approved is good for the next 2 construction seasons. So they're
Okay.
typically done for 2 years.
Okay. So what happens if a contractor gives me a mixed design that they already have? Like maybe they used it on a different project. Is that okay?
It sure can be, as long as it's for the same mix. I mean, because each mix design is specific to that mix. So as long as that mix is being specified on a different job or whatever for that same mixture with the same liquid and all that, then you should be able to accept that. So yeah, like if you're doing a local agency project or something and you specified the same, 5 EL mixture that was used on an MDOT job last year in the plant, the same plant and that everything, that mixed design should be fine. And you should be able to look at it and see that it was approved by MDOT. And so then you have that assurance that they've tested the material and made sure that it's going to meet specifications.
All right. Good deal. So I think we've talked a little bit about what products are in the mix design and just kind of the process a little bit. So what's next here? So
I
this
have
is an
I have
example.
a mixed summary example when I was talking about when we're going through the mixed design process and we've come up with our aggregate blend and now we're trying to choose that optimum asphalt content. Um, and that's what this slide here is showing. You can see we mix it at 4 different asphalt contents. And so we have, I'll use my little highlighter here if I can get that. Well, can you see my mouse here?
Yeah.
Okay. So we have, these are our 4 different asphalt contents that we blend at 5.6, 6.1, 6.6, 7.1. And so then we test each one of those blends. And what we're looking for is this 4% air voids. And you can see it's somewhere between 6.1 and 6.6. The 6.1 is 4.88. 6.6, our air voids goes down to 2.91. So our recommended optimum here at 4%, we're at 6.3% asphalt content. So that's how you kind of go through that process of doing what we call a 4-point design. So once we've got that aggregate blend, now figure out how much liquid asphalt we need. And sometimes it's by trial and error. I mean, you try to figure out, okay, it's probably going to be in this range. So you want to make sure you got a couple points on each side of it. So if we did this and maybe we picked wrong and we don't have it bracketed, maybe we got to run through it again and try different amounts. So some of that iterative process is what also, makes it take so long.
Makes sense. All right. So we can see where our asphalt content is there at the top. Is that pretty standard? Like if we're looking at maybe a mixed design from a different provider?
Yeah, this here is a mixed summary example. So that's kind of a summary of the mixed design process. It's not actually the mixed design. So I'll show you here. I've got a slide. We've got typically when we're doing a mixed design, once it's approved, we have what we call a 1931 form from an MDOT approved mixed design. And that's what's shown here on the left. And that's our mixed design. And then we have what we call a 1911 form, which is a job mix formula. So that's where we take this mix design for a specific job and put in this job specific parameters that are called out for what specification we're using, what type of acceptance testing we're using, and all those things. So I'll go through, and you asked about where do we find the asphalt content. I'll kind of zoom in because some of these are very hard to see. So the easiest way to find the final asphalt content is on the JMF because that is
Okay.
move the mixed design. So right here, oh, I went one too far. on the JMF form, right at the, oh, I went back, there we go. Our total asphalt content is right here. It's kind of in our mix aggregate gradation part of the JMF. So it's 5.29% on this example. Um, and so that's where you would find that. And that's your kind of the design. If you look down, we are also using wrap in this mix. So we have 25% wrap, and that's kind of right here, this reclaimed.
Okay.
And so we are getting some contribution of liquid asphalt from the wrap. So our total added asphalt is 4.05% to get us to that 5.29 in the end.
Okay. So where are we gonna find something like the compaction temperature of the mixture?
Yep.
Because I know last time we talked a lot about temperature and the importance of temperature.
Yes, temperature is very important for compaction of the mix, and therefore it affects the performance of the mix. So at the top of the job mix formula, this compaction temperature is shown right here. So for this particular liquid and mix, the compaction temperature is 277 to 283. And then your mixing temperature, which a lot of people want to make sure on that, if you're checking what the temperature is of the mix right out of the plant, it's 304 to 314. So those are listed on there, and that's dependent on the liquid asphalt that you're using. So different mix designs or different liquid asphalts will have different numbers there.
Gotcha. This is just is there like a rule of thumb with your compaction temp and your mixing temp? This one looks like it's maybe what, 25 degrees lower-ish.
Yeah,
Is
it's
that
about 30. Yeah, about 30 degrees lower at the
is
top right
that pretty
there. Yeah.
standard,
I
or
think
can it vary a lot?
that's pretty standard for a standard type liquid. I mean, you get into different polymer modified liquids or warm mix asphalts, and those can have wider ranges there. And there are different additives and things like that as well that can adjust that more.
Okay. We do have a question in the chat. If we go back to our where you had all the aggregates and stuff, what about if you have other mix-ins, like fibers or you had wrap in there. How does
Mhm.
other mix-ins affect things?
Yeah. And that would be shown. I guess I'll go to this part here because this shows kind of these are these columns A through F are the different aggregates that you have. So most mixes you're using, multiple aggregates to blend together to get that aggregate gradation that you want. So if the mix in, or like if you were adding fibers and that, you'd have to account for that in here, and it'd just be another column. Usually the wrap column is over here to the right. So you could add in the different things in here if you have other things that you're adding in. And it just depends on what you're adding in. If you have, you know, add-ins that go into the liquid asphalt, then they wouldn't be listed in here. These are more for your dry add-ins that act more like an aggregate.
Gotcha. We've got another question here. So the question is, what's the max temperature that a mix could arrive on site before it needs to be rejected? Is that something that you're going to find on the mix design?
Um, the mixing temperature that's shown on the mix design is that maximum mixing temperature. The specifications are usually call out like if you are 30 or 40 degrees above that, then you can look at rejecting that. And those are
Gotcha.
put in there so that you don't overcook the liquid asphalt. Good
Good
question.
deal. So you are going to have to do a little bit of math to figure out
Yeah.
you need your spec and your mix design. You need all the pieces of paper
Yes.
to make this work.
Yeah,
All
because
right.
and that's a good point, Ingrid, because like the mix design part of it is part of it. The specifications and the acceptance testing and all that. It's a whole system of checks and balances, really. Yep.
Yeah, so not one piece here.
Yeah.
All right. So I've got an acronym here. NMAS. Is it NMAS? Is it
Nominal maximum aggregate size is what, or nominal
all
mass
right.
is what we call it. And that is a way to characterize what type of mix it is. Um, and the way that you calculate nominal maximum aggregate size is it's one sieve size larger than the first sieve to retain at least 10%. So um, let's see, like just looking at the combined gradation of this mix design here, which is this far right column. So the first sieve size that retains 10% would be the 1/2 inch. So this would be a 3/4 inch or 19 millimeter mix, we would call that, based on the nominal maximum aggregate size.
And that combined gradation that includes all your aggregate and the wrap,
Yes.
correct?
Yep.
Okay.
Yeah, that's your, once you blend everything together, because when we're putting together a mixed design, we have to separate out each one of these aggregates and then run it through a sieve analysis and get the whole gradation band, for each one of them. And then we combine that based on our blend percentages to get that
Okay.
combined gradation. And you can do that mathematically, and then you can, as you're running, you can get a sample and test that to make sure that
Okay.
it's meeting that.
So I've got another question about temperature. The compaction temperature that's on your mix design, is that the temperature when the roller can go on? Is that, we want it to be at that temperature and we're rolling? Or is
Yeah,
that,
it's um yeah, this one here has a small range on compaction temperature. So I think that's the maximum compaction temperature. Somewhere in that range, you shouldn't be on it yet. Yep.
okay,
Yeah.
gotcha.
'Cause when we talked about, I think we talked about it at the last webinar on, the compaction, time available for compaction. And, sometimes you can still compact the material down to usually about 180, 190 degrees. Once it gets cooler than that, you're not adding any more compaction. You're just getting roller marks out of the pavement. So, yep.
All right. And I do have a couple of questions. We are going to be sending out the recording for this and we'll send out Chuck's slides as well at the end here. All right. So how about the asphalt content grade? Let's talk a little bit about that.
Okay. And where it is on the form.
Yeah, how do I find out
Yeah.
what I'm
Like,
using?
yeah, looking at the 1911 here, the JMF, it's right down here with the asphalt binder. So this is the grade, and then this is the certified supplier of that binder. So MDOT keeps a list of certified suppliers, and they test the material from them to make sure that, when they say they're giving you that grade, that it's meeting that as a checks and balance. They're also taking samples while the mix is being produced at the plant. So
And that grade, that's always it's two numbers with a dash. What are those numbers telling me?
yeah. So in Michigan, we use a performance graded system, so PG. So this would be a PG 58 minus 28. So 58 is your high temperature designation, and minus 28 is your low temperature designation. So, and those are usually specified by region, by where you are in a particular environment and all that. And it's to assure that that mix will perform over those certain temperatures. We could talk about that for an hour if you get in the whole PG grading.
Yeah. So if I change that asphalt grade, do I need an entirely different mix? Do I have
Mixed
to start
design.
over? Yeah, do I have to start over?
Not necessarily, no.
Okay.
A lot of studies have shown that, if I do a mixed design with a certain aggregate structure and that, and I switch the liquid asphalt that I'm using, then it's probably going to still meet all that stuff. There are some specifications out there where if it does change, it is required a new mix design, but I would say as in general, no, you don't need one. The good example is where we have like a mixed design, and MDOT has what they call high stress areas. So if you've got a mixed design for, a 5E ML or something, and then for a short stretch, you've got to switch the liquid over for the high stress application. That's a simple change to your mix design there.
Okay,
Not having to go through a whole new process.
good to know.
Yeah.
Yeah, especially with our supply chain, sometimes supply chain can make a difference in what's available to us.
Yeah.
All right. How about where am I finding the air voids? I know we talked about that we're aiming for that 4%.
Yeah.
How do I find that where we're at?
And here I'm going to kind of flip. I'll show you on both forms because it's different on both forms.
Okay.
So in our mixed design form, the 1931, as I said, we do all of our mixed designs at 4% air voids. So that's right over here on the left. And so that's what we test everything to, at 4% air voids. And then in production, what we do with a lot of our mixes, any top and leveling mixes, we regress them to 3% air voids. So on our job mix formula, the air void is at 3%. So that's where that change occurs. These are both from the same mix design, and you can see on our JMF, our total asphalt content is 5.29%. And if I go back to the here on our mix design, our total asphalt content is 4.92%. So by regressing from 4% air voids to 3% air voids, we added almost 0.4% of liquid asphalt.
Okay. So yeah, those numbers, you should expect that they're not going to be the same on each form.
Yes.
If they're the same on each form, something has gone
wrong. Or somebody didn't regress their air voids down to 3%. Some specifications regress down to just 3.5%. I think the MDOT local agency says that you should regress down to 3.5, or you can go down to 3. I've always suggested going down to 3, especially for lower volume roads, because we're getting more asphalt in the mix, going to make that mix more durable and less susceptible to cracking.
Okay. Let's see. Are there other additives? For example, are there additives that you might want to add to your mix? This person was asking if there is anything that you could add to improve resistance to salt and snow melt chemicals on your roads during the winter. If you did have one of those additives, where would you find that was being used? Are there other?
I'm not aware of anything being used for salt or added. I mean, salt in that doesn't really cause a problem with asphalt mixtures.
Right.
I don't know if that'd be just if you did have an application where you needed to do something like that, I would assume that would be added into the liquid asphalt itself, just because there's not a lot of other ways to add other liquids into the asphalt plant.
Yeah, exactly. There's kind of really the
I don't
only
know
the
that it
one.
would show up as a separate column on there. There'd probably be a note on your liquid asphalt supplier.
Good. So this person had the question, why not just design for 3% air content from the start instead of designing for 3 and then regressing, or designing for 4 and regressing to 3?
Yeah. The problem with designing right at 3% is you can close up some of those air voids with something other than liquid asphalt. So when this change came on the MDOT side of things, we wanted to find a way to get more liquid asphalt in the mix because we were having durability issues with the super paved mixes. So what we did was, we design at 4%, let's regress to 3% with liquid asphalt rather than just designing at 3%, because your aggregate structure, fines and things like that, you can close up those air voids that way and not add any more liquid asphalt to it. And we felt like that wasn't going to help our durability issue.
That makes sense. Let's see, what else? How do I determine my AWI for a fine aggregate? What is AWI?
AWI is aggregate wear index, and the Department of Transportation has specifications for each mix. You have to have a certain AWI value for the top course mix. It's basically a measure of how the aggregates in that mixture are going to wear over time. Is what they don't want to happen is to lose skid resistance on the pavement. And if there are certain types of aggregates that wear and polish really quickly, and then the pavement can become slippery. So, and there are the different, MDOT does a lot of the AWI testing on materials from different pits around the state. And it's really determined by looking at the angularity index and turning that into a percent crush that's read off a nomograph. They have a Michigan test method to develop and figure that out.
Okay. And that is different than like your LA abrasion test? They're
Yeah,
not the same test.
it's not the same test. No, LA abrasion is a different test that they use. And that they test materials, and they have a circular wear track in Lansing where they make these little bricks and run this wheel around and look at how that performs. And so they assign those values as well. And that's another thing that, you know, by specification, your blend has to be able to meet that as well. So that goes, both of those things go into, you know, what types of aggregates you're choosing for your mix design. So in order to meet those specifications, you have to use certain aggregates. Both of
Okay.
those results and values are good for 5 years. They usually check those every 5 years.
And then I guess one of our last questions here, we're almost at 12:30. We will stay on a little bit. I did drop into the chat the certificate of attendance survey that lets us know, you know, other topics you might want to talk about or hear about. And also allows you to get your certificate of attendance. If you are attending with a group of people, you can get, all of you can get you just keep putting the names in. If you're attending by yourself, there will be a question that asks you, how many people are you attending with? And you have to put in the number 0, otherwise the survey bonks. It doesn't like, you can't type in 0, you can't continue on with the survey. You got to put in a 0 there. But I guess for one of our last questions here before 12:30 is, how can we check that mix designs submitted to the, you know, that are submitted to the owner or the engineer by the contractor? How does this process work?
Yeah. So if you get submitted this mix design from a contractor, a producer for a certain job, and it's this 1931 form, this has all the information on it that you know has been tested and checked. Um, so you really got to check that against the specifications. So if you're using the MDOT specifications, you go to the MDOT tables. There's multiple tables. There's tables for, you know, your volumetrics for the mix. There's tables for the aggregates that you use. And you got to check that it meets all of those. And like we talked about before, if they give you a 1911 form, like that was already approved for a job or something, then you kind of have that assurance that, hey, this has been checked by MDOT, and so it should still be good as long as it's not, you know, 10 years old.
Okay. So we got a question actually about the 1911, which is handy here. So
Uh-huh.
there at the bottom, you've got all of these, there's GMM, GMB. Can you explain what those G and then a
Yeah,
number, what
yeah.
are those?
Those are your gravities, basically. So your GMM is your theoretical maximum gravity of your mix. Your GMB is the bulk specific gravity. So the GMM is your gravity of your mix loose, and then your GMB is your bulk specific gravity. So we've taken that loose mix and we've compacted it, and then we get, and really those two tests are very important for calculating your air voids, your VMA, your VFA. So those are, you need those values, they're tested values that you need for your mix in order to calculate what are my air voids, what are my VMA, all your volumetric properties. So those are very important. The GSE, GSB, well, GB, that's your specific gravity of the liquid asphalt. So you know that as well. And GSE and GSB, those are your effective specific gravity of your aggregates and your bulk of your aggregates as well. So that's kind of what all those are. Fines to asphalt ratio, that's something that's always checked. There are specification limits to that, and that's where, how many fines do I have below a certain sieve, and those are my fine aggregates, and you want to make sure that that ratio doesn't get out of whack. I believe the spec on that's like 1.4 or 1.2, depending on your mixes and stuff. And then it changes for the acceptance testing too, to account for plant breakdown and different things like that. So,
And we had a question about the final air content when your mix is regressed, and it's on that second from the bottom line there.
yeah, yep, that's here, the air voids, the 3% on here. Yep. That's how
So
you know that that one is for your actual production,
okay.
where the other one.
So we've got a question about so all of these things that we've talked about, are all these things that do they need to be discussed in your pre-production meeting, or are there additional things that should be talked about during a pre-production meeting?
Yeah, there's a lot of stuff that gets talked about at the pre-production meeting. I mean, mix design's like one little thing. Do we have an approved mix design, and all that stuff? I mean, there's a lot of stuff. You can even see on here that on the job mix formula, the plant certification date, there's a whole process before you can even get into production on things that have to be done. So each plant gets certified each year. The mix design's got to be checked and make sure they're up to date and all that. At the pre-production meetings, you're talking about, job specific things on, timing, how we're going to test, what kind of tests we're running. You can see on the job mix formula here, the testing option. So how are we going to figure out the asphalt content when we're doing our acceptance testing? We have two options here in Michigan: ignition furnace, that's what this IGN is, or vacuum extraction. So
Um,
there's a whole host of things that get talked about at pre-production meeting, scheduling and different things like
yeah,
that.
maybe
What
we do a
lab is
webinar
doing the
in the future
QA?
about
Yeah.
pre-production meetings.
Yeah.
I got another question here. Do you check the specific gravity values when you review a mix design? Is that something that you should be checking? Or should those be pretty standard?
Yeah, they're usually pretty standard, but MDOT does check those as well. Because when you're submitting a mix design for approval, you have to submit all of your different aggregates and your liquid and all that. And then basically MDOT's putting together your blends and going through all this testing as well. So even though you've tested it and that, and you submit all that material, MDOT is checking that as well. They do have a system called a paper, an express mix design submittal process. So people who do submit a lot of mix designs in that, sometimes there's just a paper review and they don't do all the testing. But they can always test any of that material whenever they want. So that can be checked as well.
Okay. How about in terms of testing? So, you talked about IGN. That's not the only type of testing. Are there, is it dependent on like the type of job? How do you know, maybe what to expect in terms of testing?
Yeah. As far as like the ignition furnace versus like vacuum extraction, I would say the predominant mode is vacuum extraction. There's a few areas of the state and in labs really that prefer the ignition oven. Some areas of the state we don't use the ignition oven just because of the types of materials we have, and it's harder to get a good number. You have to. There's a lot of testing up front with using the ignition furnace oven process. We have to have special samples made together to get correction factors for the different ovens and the different aggregates. It's a whole process, but yeah, I would say the majority people use the vacuum extraction. That's where people have a lot of familiarity with, and just because of some of the aggregate issues in some parts of the state.
Okay. And I guess in terms of your aggregate testing too, are there additional tests besides, your your LA abrasion, your AWI, are there, you know, your standard sieve, those kind of things? Are there things beyond that that people might need for a specific project?
Yeah, when you go into looking at, you know, you've got your standard sieve sizes here, so that's your gradation. And then you have a lot of different things that you're looking at. One face crush, two face crush, LA abrasion, angularity index, AWI, yeah, all that stuff. You're looking at soft particle percentages, flat and elongated percentages. So yeah, there's a lot. There's a whole section in section 9 of the spec book. There's 4 or 5 tables that deal with the aggregates and the aggregate testing that gets done.
And then I guess I have a question from as a geotechnical engineer, I know that the stack of sieves, there's not just one, there's many different stacks of sieves. So is that stack of sieves, those sizes, is that standard for all of the Michigan aggregate or asphalt designs, or could you maybe have different sieves that either get taken out or put in?
Yeah, these are pretty much the standard sieves that we look at when we're putting this together. And then there's certain control sieves in the specifications where there's not a specification on each one of these sieves. There's control sieves that it has to be in this range on this sieve and on this sieve. So yeah. But when you're testing it and putting together a mixed design, you really want that full gradation here to see how it's all interacting together.
Yeah, let's see. Another question about aggregate specifically. Does the aggregate pit, like where your aggregate is coming from, does that have to be MDOT qualified or like pre-qualified for like local agency projects?
I don't know if it does necessarily. I know that like the pit numbers up here, so those are, you know, like approved by MDOT and have been tested by MDOT. So those are going to have those AWI values and the abrasion values and things like that. If you were using a pit that didn't have that information, it might need to be tested then.
They'd need to get it. Yeah.
Yep. Yeah. So that you'd have those numbers. So a lot of the stuff that MDOT does, you know, that certifies, and they have the certified supplier lists and different things like that. Those are things that they've tested and have used over time. So they kind of have a history of it as well. Because some of these numbers change over time, like AWI values and LA abrasion numbers. Those can change over time as you get into different veins of the aggregates and the pit itself and things like that. So,
and I think you did mention, but just as a reminder, how long are those tests good for if they have been done?
The AWI and abrasion, 5 years is what MDOT says. Yeah, on their specs.
And any pit, if they have done the test, they should be able to provide you with the results so that and with a date on it.
You have that number. Yep.
Yeah. All right. Let's see. We've got somebody who would like to know just a little bit more about that compaction temperature range. So that was on that 1911, I think.
Yeah. That maximum compaction temperature range there.
So that's the temperature where we want it to have cooled down at least that much before we're starting to put a roller on it.
Yep.
Which makes sense why it's a little bit tighter range than the mixing temperature in terms of our temps there. All right. So how about just as we're looking through here, the on that 1911 there was the VMA and the VFA. What are those telling us there in the middle there, that 13.9?
Yeah, there's like minimum specifications for VMA. VMA is the voids of mineral aggregate. It's kind of like it's like your air voids minus your asphalt content, I think, or something like. There's a calculation. I'm drawing a blank on it right now.
That's all right. It's one of those like the what is it, the little bit of water that's around the aggregates and concrete design, those kinds of things. Yeah.
And then it gets into like, you gotta subtract out some stuff for absorption and stuff. I think that with the voids filled with asphalt, that's how much of that void space is being filled with asphalt, and that creates your paste basically of the liquid asphalt and that. And there's specs on those of, usually it's gotta be above or below a certain point. Yeah.
So this is a question too, I'm
It's
seeing,
part of the volumetric testing, really.
yeah,
Make
gotcha.
sure you're meeting that spec.
So in 2020, MDOT updated their specs. So I see that that standard specification date is that 2020.
Yep.
Are we still like, could people maybe be seeing mixed designs that had a pre-2020 date on them? Would those still be good, or would they not be something that folks should use?
If there were some jobs that were put out with what was it, the 2014? No,
So I think that's
like
right.
that. 2000, yeah. The
Something
previous
like that.
book that may have, been within the last 2 years, and it was an approved mixed design, and might still be good, but
Okay.
you just have to check that way. I mean, um,
And then another question about temperature. We got lots of temperature questions. That mixing temp, that's the range that the asphalt should be in the hopper, that 304 to 314.
yep.
Okay.
Yeah, because that makes sure that, then it's viscous and it can coat the aggregates properly and stuff. Yeah.
All right.
And that's specific to the liquid asphalt that's being used. Obviously, if you use warm mix additives or any of that kind of stuff, that's gonna be a lot lower there.
All right. Um, and then another question, another temperature question. What temperature should the mat be?
Well, that gets
Um,
into compaction temperature, so that's where you're checking the
yes.
mat temperature, and that has to do with, the when you're compacting the mat, you wanna make sure that it's a certain temperature.
And we've got a couple of upcoming webinars with Chuck as well. The next one on the 3rd is selecting the right asphalt mix design. And then on the 10th, there's a asphalt pavement inspection basics that we're going to be talking about. So we can talk more about some of those types of questions as well.
Yeah, definitely.
Yeah.
Yeah, and like the asphalt pavement mix design one that's gonna be more of a presentation,
Yep.
and the asphalt inspection basics will be more of a question and answer like this one was today.
Yeah. All right. Yeah, we've got a couple of other questions. Another one about low temp allowed during compaction. Again, that's going to be more to do with your specifications. So you've got your mix design and your specifications. They go
Yeah,
together.
yeah. And also it kind of depends on out in the field too, the way that the mix is rolling down itself. I mean, um, if you're not doing like coring to check density and things like that, if you're doing, you can do the number of roller method where you're just doing roller pass checking. You're not getting an actual density, but you can be able to see that roller density curve, and you know what your maximum compaction is. Um, down to 180, 190, those are rules of thumb. It's really dependent on each mixture and what what that mixture, how it reacts.
So speaking of some mixtures, there's a question of, is there a way to tell on the JMF if a mix is a warm mix? Like, is there something that you should look for that would tell you like, oh, this is not my standard mix. This is a warm mix instead.
Excuse me. Yeah, you would see, well, that mixing temperature obviously would be the
Would
first
be
place to tell there, but it would also have probably a note in there that you've added any additives to the liquid asphalt itself.
is there anything other than that, like the mixed design number or any other things that might indicate to you um some important information about your mix, maybe the type or um uh other info that you might be able to pick up,
Off of yeah.
like the type of mixture, that
Type of
3 EMF.
mixture, the 3 EMH, so that tells you it's a 3 mix, medium, high volume traffic, mixed design number. every mix design has a specific number assigned to it. Sometimes they'll might have a mod behind it, like, if you get into doing JMF request changes and things, that's a whole nother subject. Um, and the mixed design numbers, and that's really a tracking thing for, you know, the DOT, obviously, because that's who we're talking about here, but they have catalogs of all their mixed designs, and then they know what's been tested and checked and all that. As far as getting any other information off of here, yeah, I think we've kind of covered most of it. We've got the, yeah, the grade of the asphalt binder and the certified suppliers here. You know, you got your gradations, you got your materials and pit numbers and the percentages.
And in terms of performance, you've got your asphalt mix design, but then also how it's placed, how it's compacted, how
The
it's
pavement design
maintained.
itself, the, yeah.
Yeah. So your mix design could be, you know, it's
Perfect.
one piece of the puzzle in terms of performance.
Yes. Yeah. And I always tell people I can have the most perfectly designed mix, the most perfectly made mix, and if I don't compact it properly out in the field, it may not perform.
Yeah.
So it's all a whole process that got checks and balances along the way. Make sure you're using best practices in order to get that good performance.
Good deal. All right. I don't see any other questions. We can hang out here for a little bit longer. I had dropped that survey link into the chat for you guys. If you, I can do that again here. But yeah, if you've got any other questions, Chuck can hang out here for a little bit. But otherwise, thank you guys for coming. And we'll hopefully see you on the 3rd for our selecting the right asphalt mix design for your particular project. So yeah. Thanks, Chuck, for this. This was awesome. We really appreciate that you take the time out of your day to tell us a little bit more about asphalt.
Thanks, Ingrid. Anytime. Yeah, if anyone has any questions, feel free to contact me. That's what I'm here for, is to help educate people. So thank you again.
Oh, we've got another question here in the chat. Does bond coat need to be filled out on the 1911, that JML? If you're using some of those other products, or where do you find that?
Yeah, bond coat is kind of a separate thing. It's not really included in the mix design because it's not going into the plant and being mixed together to produce the mix. So yeah, that's a separate certification and issue there. There's whole spec on bond coat and quality control plan for bond coat and checklists and all that kind of stuff.
Yeah, so if you're going out to do the inspection, I know we won't get too ahead of ourselves.
We'll
but
talk about that
if you are
during the
going,
inspection class for sure.
yeah, if you're going out to do the inspections, there's quite a few pieces of paper and bits and bobs that you need in order to have all the information.
Yeah.
All right, good deal. We'll give you a little bit more time to get the survey link if you're having some problems. Here, I can I'll put the link into the chat just by itself. I know depending on if you're on mobile, it might be difficult for you to just click the link. You might have to copy it into your browser. Sometimes with mobile Zoom, it doesn't let you just click the link and have it open automatically. All right. And yeah, we have a request for a geotech seminar. If you have some specifics about what you would like that to be about, we can definitely provide something like that for sure. If you've got a specific topic or specific project that you'd like to know more about, we can talk more about those. We'll give you a few more minutes to get that link, and then we will say good afternoon for today, and we will see you. Yeah, we can definitely do some of those topics. We'll save this chat and we'll have something for the future for sure. I'll get your ideas. Thank you, everybody. All right. Thanks, everyone. Thanks again, Chuck, and we will talk to you again next week.
Right. Sounds good, Ingrid. Thank you.
Thanks,
Thanks,
everyone.